Thanks for joining. Today we are in day number 16, and today we have one very important topic that we want to learn: quality of service, QoS. Now, quality of service is such type of service which is something based on the requirement. If you have low bandwidth, then you need quality of service. In case you do not have low bandwidth, you don't need it. So QoS, it depends upon the requirement. But there is one use case related to QoS, that is still you have plenty of bandwidth. In case if you have plenty of bandwidth, still you need QoS. In that case, you need QoS, quality of service feature, for classification and marking. So when you have congestion in network, you can go and obviously you have to apply the QoS. But in case you do not have congestion in the network, still you need it for classification and marking. Why we are doing the classification and marking for the traffic? So we can go and prioritize. We may have high priority traffic, we may have mid priority traffic, we may have low priority traffic. Like that, we have the categorization of traffic. For example, the business traffic, for example, SAP traffic or any type of business data, they should go into some high priority queue rather than the other example. Someone is using Facebook or YouTube if it is allowed in certain time period, or if someone is using some junk file transfer, etc. Those should not be treated as a business traffic. So those traffic, we can mark those traffic as a very low priority traffic, like it will go via the default queue or will put in the default bucket, etc. So for that reason, classification and marking is important. Either there is congestion or there is no congestion, still we are using classification and marking. But in case of congestion, we can go and use other techniques such as queuing, congestion management, policing, and shaping. All these methodologies that we can see here, like queuing, provide put that data or put those files in a queue. Congestion management, what type of algorithm we have related to congestion management. Now there is one example related to congestion management. Suppose there is a traffic, and then due to that traffic there is roadblock. But in that case, suppose you have ambulance. By any case, ambulance is also there in that path, in that road. Then you have to go and provide the route path to that ambulance, because it is coming with some priority. It has a label of priority. Right? So on those cases, how we can go and use such type of algorithm that even before the congestion will happen, how we can go and predict the congestion, and in that case how we can go and start dropping the traffic as per the classification and marking, which is the least priority traffic that I can drop. Right, so that is the congestion management. Then you can see policing and shaping. Policing is simply that if you are limiting the threshold, just cut down the bandwidth. And shaping is something that have some sort of buffering, that you will not start dropping the traffic, but you will provide some sort of buffer because you are using shaping methodology. On other hand, policing, with policing, you have to go and chop it down, like it will start dropping the traffic. Now I created one chart here. You can see the chart. Classification. What's the purpose of classification? That differentiate traffic types and apply QoS to the policy. Classification and marking. These two techniques are there just to categorize what type of applications are there. You may have classes of different classes of traffic, and you can categorize the traffic class. So for that we are using classification and marking. Then what about queuing? Queue. ensure high priority traffic is transmitted before the low. The use case of ambulance type of use case, like if we have some traffic, for example voice traffic. These voice traffic, they have TTL value, time to live value, less than 150 millisecond. So that means that if these traffics, they are not delivered to the destination within 150 millisecond, they will auto burst. They will lose their significance because their TTL is less than 150 millisecond. So that means that voice traffic or video traffic, etc., you have to put some sort of priority in the queue. That means if you have different type of queues, Q1, Q2, Q3, etc., so you will see that the hardware structure is like this, that if you have the hardware structure, in this hardware structure, you will see that you have different type of queues. You will see that you have Q1, Q2, Q3, Q4, Q5. Generally 7 or 8 queues principles are there. But in that 8 queue, you may have one queue for priority. These are the queues, for example. What exactly this is? This is one of the router. Within that router, I'm showing you one pipe is there, and assume that particular pipe is nothing but the queue means buffer, some sort of buffer you have. The important point here is this, that the traffic will come and hit to the ingress. This is what ingress of the router, and it will leave to the wire, because here what you have done, here you have connected with some interface. Here you have the WAN connectivity. This may be your LAN connectivity. So connectivity wise, if we go and try to draw this may be my LAN and this may be my WAN. Generally in the LAN connectivity, you have higher bandwidth. This is my local area network. That means I have connected with some router, some switch. And here I have the WAN connectivity. In that case, I am connected with some ISP router. Right? Suppose this is our router number 11, and ISP router, we have router number, I think router number 23 or something is our ISP router. But anyways, so you will see here that traffic that is coming from inside it, we have different type of queues here, right? Different type of queues. In those queues, you can clearly see that on those queues we have one priority queue as well. So what we will put in the priority queue, we will go and put in this priority queue, we'll go and put the voice related traffic. But how you will go and put the voice related traffic? Because we have done the classification and marking, so that means that router, when they will get the traffic, it will understand that this is related to voice. That means it should get delivered within some specific time or a specified time. So that means I have to go and put such type of traffic in which queue? In the queue that is high priority, where we have put some priority, some bandwidth reservation, some dedicated bandwidth. So I can go and put that traffic within this, because it has to go and get delivered within less than 150 milliseconds. So that's the logic we have actually for classification and marking, and then the queuing. Then congestion management. What exactly this congestion management will do? Congestion management will do some sort of intelligence, some sort of prediction, you can say. In other words, it will go and predict the traffic pattern, and you can say random detect DHCP based. Detecting something, it is detecting, predicting, and according to that it can go and take some decision. We'll see that It can go and drop the traffic, or it can go and do some sort of tail drop, or it can go and do some sort of round robin method, weighted round robin method, etc., etc. So it has multiple options that it can go and take action depending upon the predicting the traffic pattern, and then it will go and take some action. Legacy policing. Policing is something that enforces traffic policies and ensure fair use of network. Policing will simply, you see, monitoring the rate of traffic and enforce limits by dropping. See, policing will simply go and drop the traffic. If it will go and breach the specified bandwidth that you reserve for the traffic, after that a specific bandwidth, suppose the bandwidth is increasing and this is your limit. Now, if you try to go beyond this limit, then it will start dropping this traffic. But in case of shaping, if you are reaching the threshold, still you have some buffer. Again, you can reach to somewhere, but after that, anyways, it will go and start dropping the traffic. But it has some sort of buffer in between. So you can see that delaying the packets to conform to a specified traffic profile is smoothing traffic burst. You can do some bursting here. You can't, suppose you have buffer of 100 Mbps, you can't go and use 200 Mbps, but you can go and use 105 Mbps for certain specific time period, because you are doing shaping, you have some sort of buffer, you have a small buffer, right? So that's the QoS we have, like classification, marking, queuing, congestion management, policing, and shaping. So why not let's go and check the examples related to this. So then what I have done, that I have created the slides where you'll understand classification and marking. Classification, we are creating different class of traffic like audio, video, voice, HTTP, SIP, you know, file transfer, network traffic, etc., etc. And then in the marking, we are using some sort of QoS. This is layer 2 marking. TOS, this is layer 3 marking. So either we'll use class of service or type of service, layer 2, layer 3 marking, and then we will provide that marking to those class of traffic. So we have different spectrum for marking. For QoS, we have 3 bits. For TOS, we have 8 bits. With 3 bits, we can go and create 2 to the power 3. That means 8 different type of classes or the marking. And with TOS, we have 8 bits. That means 2 to the power 8. That means we have total, I think, or how much? 264 or something. 2 to the power 8 number of markings we can do, but in that 2 to the power 8, actually 3 bits are reserved. So we have actual marking 2 to the power 5. 2 to the power 5 means 2 into 2, 4, into 2, 8, into 2, 16, into 2, 32. Only 32 marking is there, right? If we have 2 to the power 5. So like that, we can do the markings related to traffic. So classification and marking, we have that as spectrum to do the classification and marking. Then queuing, you can go and put high priority traffic. Means you can go and give some sort of priority within the queue. So as per the hardware, I should have one blank slide. Yeah. So as per the hardware, you will see that you have queues defined. All hardware has different type of queue. For example, Nexus, they have different type of queues. For Catalyst switches, different queues. For routers, different type of queues. But queues are there that you can put the traffics in between. Suppose Q0, then Q1. I'm using black color, so it will lose. Let me go and use some other color. So you have queues like Q0, Q1, Q2. Suresh is joining. Okay, like allow him. then you have Q3, and then you have some priority Q1, priority Q,
Hello,
for
everyone.
example. Thanks for joining. Priority Q2, then suppose I have queue number 4, then suppose I have queue number 5. Like that, you have the queues defined. Now, in these queues, the priority queue, you can go and put some voice related traffic like that. So what this will do, this will go and do the congestion management. For congestion management, we are using the, sorry, for the queuing, for the purpose of queuing, we are putting the priority over the class of traffic. I will show you in the example how we'll do that. Then congestion management, we have a congestion management is something that control the packet loss and delay during the periods of high traffic. So what it will do, it will do some sort of prediction. As per their prediction, it will start dropping the traffic. You can see random early detection. It has different type of algorithms like red, random early detection. Start dropping the traffic before it will go and hit the congestion. Red, weighted random early detection. Tail drop, simply go and start dropping the traffic which has low priority. Like that, it will go and provide the efficiency within the network with the drop of the traffics. Then policing and shaping, two different things. We study policing will simply go and chop up. It will cut down the, it will start dropping the packets. It will cut down the traffic. But shaping will go and provide you some sort of buffer, right? And then we have the lab. I will go and show you in the lab as well. But for you, the good table is this. Only if you go and understand this table, and if you go and rewatch this video for first 20 minutes, I have explained that what is, why we are using QoS and then classification, marking, queuing, all those things. Anyways, I am going to show you here with one of the example. So here you can see, when you go and configure it, how it will be, you will go and define the class map. In this class map, actually, you can even call access list as well. You can go and call any type of protocol as well. The class map is very powerful. First, we are creating the class map. Then we are creating the policy map. And within this policy map, we are calling the class map or the class. And then we are putting some policy in this class. And then we are applying to the interface outward or inward. Now, the direction of these policies are something like this. Generally, that's the best practice actually, that if you are a router and you have interface that is going to the ISP. So over the ISP interface, you are applying the traffic inbound, outbound, both direction. But if you are going towards the LAN network, then generally the traffic direction is inward. So if you are receiving the traffic from outside, you will do some classification marking. In the LAN network, generally we are classifying the traffic and then we are receiving it. So we are generally the direction is inward, but over the WAN devices, we are applying the out and in both direction. Generally, this is the best practice that we are using. Okay. So let's go and build this policy. Let's try to understand this. What are the stages you have? The stages you have. So first of all, what you want to do, you want to create the class map. Then you want to create the policy. Obviously in class map, you have different type of things. You can call the ACL, you can call the protocol, you can match the DHCP. It is, you have these operations. Then you will go and use the policy map. In policy map, you can go and call the class. And then you can use shaping, policing others, any other policy. And then third, you have to go to either WAN or LAN interface, LAN or WAN interface, apply it. The direction, in WAN we are applying generally in both direction, LAN generally in the inward direction. So these are the steps that we have to go and follow. Classification, and then class map, and the policy map, and then apply it. That's it. So why not, let's go and try to build the policy. Here you can see a few examples related to voice traffic. So voice traffic, we are giving the marking as expedite forwarding EF DHCP layer 3 marking. And then policy map, we are calling it, and we are setting, again we are doing the same thing, setting the DHCP EF, and then over the interface we are applying to the inward direction. Again, I can see over the switch also same policy, but you can see that in the switch for voice, even I am providing some priority as well. Policy map class was priority. So we can give the priority. You can see the policing example as well, and you can see the shaping example as well. So the default class default, we are giving the shaping of maybe 100 Mbps or 1 gig like that. And here you can see that policing. So configuration wise it's okay, it's easy only. You can configure it and you can apply it, and then finally you can go and verify this. Let me pull the router and let me go and try to build this policies. And let's perform this. So let's build it, say a class map, right? Word. We'll go and create some more class of traffic. And now you can see that it is telling match all, match any. All means that you have everything in that, like it will be AND operation, or means this or this or this, right? So when we have type as well, that is for even for security. Class map type inspect, if you are using class map type inspect, that is for firewalls and the generally we are using this type of class map in firewall when we are using class map type inspect. Okay, so let's go and move. Say I want match any, just to show you. This is the OR operation. HTTP, my traffic is HTTP traffic. And let's do like this. Instead of HTTP, web traffic. Now, if I type question mark, you can say description match. Now you can match something. You can match the protocol as it. You can match the cause, destination, DHCP, input interface, IP, packet, precedence, protocol. This protocol. This is important. So you can match the protocol. You can match the access class. This is nothing but the access list. And you can match the DHCP, right? So match the, suppose I have some access list for this web traffic. I haven't created, I'll create it. Named name web ACL and match the protocol. For that, you can see list of protocol. WebEx, WebSense, Webster. You can see HTTP, management, secure, HTTP, Okay, web. So these are, I am matching a, let me quickly show you that class map. So you can see that we are creating one class of traffic classification where I'm matching some access list, I'm matching some protocols. Even I can go here and match the DHCP, and now you can see that DHCP, different type of labels in DHCP, 1.1.1 to 1.3. This is something like 1.1 is least priority, then 1.2 having more priority than 1.1, then 1.3. Then 2.1 having more priority than 1, then 2.2, 2.3, then 3 having more priority than 2 and 1, then 4 having more priority, like that. Finally, you will see that we have something like EF. EF is the expedite forwarding, generally which is applying with the, this is applied for the voice traffic. So here I can go, since this is also high priority traffic, so I can go and map with A43. Let's go and create some other class map. This time uh, that mid traffic, mid-level traffic, and match DHCP 1.1, or maybe the mid traffic, so maybe 3.1. Then I'll go and create one more traffic that is low priority traffic, where I'll go and match the DHCP default. Then I should go and create the one more class map, for example, voice, where I'll go and match the DHCP as EF. Now let's go and check the class map. So now you'll see that we have created the class map for mid traffic having these DHCP. Oh, I should use only one DHCP since I have given two, so it is showing two. But anyways, remove that. Then you can see that we have the web ACL web traffic where we are matching the access list protocols. What's the access list web ACL? I will create this ACL, and then we are matching the DHCP as well. Then we have the class default. We haven't created it. By default, there is a class called class default, low priority and what. Like that, we have created the class map. That's the stage number 1. Create the class map. Let me quickly go and create one access list. Standard name web ACL permit suppose 10.10.0. This is my internal network. So now we have this part 1, creating the class map. Then you should go and go inside the policy map. But before that, we should know what are the classes we have. So now I can go to the policy map, my corp policy. And within this policy map, we can go and call the class. So suppose I have class called voice. For this, I want to give priority and then set DHCP EF. I need this class. So we can see that we are within the policy map and the class within the class. So we are done with the class that is related to voice. Then what class we have? The next class we can go, for example, web traffic. Now for this web traffic, what I want to do, I want to give some shaping as well. First of all, for this, what was the web traffic? The DHCP was 43, and then I can do some shaping. I'll give any number, but even we can use percentage as well, say 20%, and sustain burst up to 500. So for web traffic, I'm giving the shaping methodology. Then let's exit and let's see the classes that we have. We'll go and call other class. So we are done with the voice. We are done with the web. Then what classes we have? We have low priority traffic. One this, so you can see class map or mid traffic and then low priority. So then I have this mid traffic. So I can go and call this. I can see that DHCP is 31. I should not use this 11. So for this, I can go and do the policy and bitrate, confirm burst of 1000, and then excessive burst will go and use the drop action. This is something that you are giving some bursting here of 1000 bits, but the after that the excessive burst is drop. Even after this also you can drop. It's up to us, but this is something that after that limit it will start dropping the traffic. This is like aggressive method to drop the traffic. So now we can go to the class that is class that is low priority traffic. So we have created class related to voice, then we have created web traffic, then we have created something mid traffic, and then we have the low traffic as well. So low traffic will go and low traffic, you can see match DHCP is default. So set the DHCP default, and we want to use that queuing as well. Queuing we should use in the other classes as well. So leave this as it is. Give some default here, and then finally you have class called class default. There also you can go and give some methods. Okay, I'll do that, no problem. What we can do, say drop cannot be gone. Yeah, it's something that we should give something like, you know, some queue, some mechanism here, but leave it as this point. We'll check that. So what I'm telling here is this, that when we have the class called web traffic, right? So web traffic, we want to do some queuing, congestion management technology, right? So for that, you can go and give the random detect. You can see random detect is DHCP based explicit congestion notification. This is ECN. This is also one of the methods. Costs, based on costs, discard the class. Precedence. Even you can simply leave it as it is, like random detect, enter. So the system will take decision what to do. Like that we have the classes, right? So I can go to the other class, say for example class, let's go and check the mid traffic. Yeah, random detect. Now it is telling that bandwidth or the shape command is required to configure to the random detect. So I can go and reserve some bandwidth. So bandwidth %10. So it is telling that strict policies priority key is already there, so it is not taking. So conflicts are there, that in the queues how we can go and define the traffic. But this is the overall pattern of the traffic we have. Like this is the overall policy we have. And let me quickly show you the summary here. that how we have created and how it is. So if we go and check show run class map, you can see that we have our classes. And if you go and check the class map as a whole, so you can see this, then show run policy map, you can see that we have policy called my corp policy. Within that class was priority and DHCP, web traffic, DHCP, and then shipping and random detect for the web traffic, because this is corporate traffic. We should have some more policies here. Then mid traffic, we are using policing. Then low traffic, we are using default. And then we have class default. We are not applying any policy in that. Now, let's quickly see that slides. Here you have less example actually. I have added some more examples with some more logic, and then you can go and apply it. That's the final phase. You have either you can go and apply input, output, etc. So for this, my ISP link is E0/0, and then I can go and use the service policy, say output, it's the name of the policy, my corp policy, enter, service policy input. Priority cannot allow parent level input direction. Okay, so due to priority, it is taking only in one direction. No problem. Show policy map interface E0/0 input. And if you want to see this policy, you can see this policy in action. So over the interface, we apply that interface over E00 in the in direction, and then it will tell you that QoS QoS set web traffic 5 minutes offer, match protocol, match these protocols, all the protocols that we have created. Then shaping for other class that we have created. Then you can see in that the target shape, Q depth. So all those policies, you can see even the class map default is there also in action. So all policies that in the action, in this way you can go and apply it. All right, so that's the QoS in action. I try to explain from very basic, and I try to cover all those aspects in QoS. But QoS is something that you have to study the network, and according to that you have to do the classification and marking, and then as per the requirement for the uh, latency sensitive traffic, you can go and use the priority keyword. For example, voice and videos, they are latency sensitive traffic. So for those type of traffic, you have different type of methodology how you are handling it. But for emails, they are not latency sensitive, because they are keep trying to download it within the folder, etc. So email based traffic or web based traffic, you have to use some other methodology. And suppose if you have to go and build the policy, QoS policy for your corporate, so there are so many good references, Cisco best practices references, that you can take the reference from there and you can build your QoS script for your corporate. Right, so this was the QoS session. If you have any question, please feel free to ask. Thanks for joining. Today is actually day number 17. And today we are going to discuss about CCNA security. This section will be mostly theoretical. In this, we have to learn, understand about different type of security practices. Again, that those type of things we have to go and apply with respect to our networking gear, like network routers, switches, access point, etc. You can see that the split of topics starting from 5.1, understand the key security concepts, exploits, vulnerabilities, security programs, user awareness, configure and verify device access control. This is something like RBAC, role-based access control. We'll discuss about that. Then password policy management, etc. Then this topic is something that is in CCNA level. This is something that you have to understand just the concept, but we will perform the lab related to this as well, like how we can go and create site-to-site tunnel, which is not there in our course, but because since this is important, so we will perform a lab task related to this as well.
Okay.
Then configure access layers, layer 2 security. Yeah, this is there in our project as well. DHCP snooping, and I will go and add one more topic in our assignment, CCNA assignment, that we have port security. Snooping and port security, then we have dynamic ARP inspection, then AAA, authentication, authorization, and accounting. Actually, this is falling purely entirely Cisco CCNP ICE curriculum or CCNP security curriculum, where you have to understand more about the authentication, authorization, and accounting. Then wireless security and WLAN security. Wireless, we have one dedicated session. In that, I'm going to cover everything related to CCNA wireless. So these are the split of topics we have. What I will do today is that today we can go and discuss about 5.1 up to 5.4. These are very much easy topic, easy theoretical topics. So let's start from 5.1. Key security concepts, threats, vulnerabilities, exploits, mitigation techniques, etc. What are the threats? Someone can go and steal some information or um, send some virus file in that in the network, gain some root access, privilege access, do some modifications. Those are the threats we have. One of the known threat we have is the ransomware attack. Like someone can go and completely get the authority over some hard disk, some drive, laptop drive, and then they will send one message over the screen that your system is hacked, and if you pay this much amount of money, then only you will get the access. What they are doing basically that they are locking or encrypting the drive, and to unlock or to decrypt the drive, they will send you some key via email or via any media. If you go and use that, then your system will get open. Now, related to this ransomware attack, so many companies, they have this ransomware attack and they have paid, no one knows about this. This ransomware attack was one of the top attack we have, because this is something that directly hackers or that group, they are gaining access, and then they are getting paid, and then only they are removing the they are releasing the key to open that hard drive and disk, etc., etc. Now there are separate measures related to protect from ransomware. In this security discussion, we are going to discuss in general, like these are the things and these are the mitigation techniques. But security is always in the layers. You can't put only one layer of security and feel that I'm safe. Security is something that will be layered. Always you have to layer one, layer two, layer three, layer four. Like that, you have to go and grow your security perimeter. So first of all, let's check these threats like virus, worms, trojans, ransomware, spyware. Now, where? Where is coming actually from software. I think, yeah, from software. So these are very much like software type of attack, means some script is there, some, for example, virus. I have one book related to virus, a complete book I have. related to virus. In that, they have explained that, okay, some code is there which can go and explode after some period of time. That means in that code you have some sort of TTL or you have some sleep timer, and after that it will get exploited. Now these viruses that we have, they are like a small programs, and those programs are something that they are growing in number. So they can go and attach with some folder, and again they can go and attach with some other folder. They have some split, like they can split, like some worms or something, like, they can split in 2, 4, 8, 16, like that, and then they will start infecting the folders or files or system, etc., etc. These are the malicious code. Worms are also like malicious code. Trojan is something that is uh, encapsulating, like, when you're sending some IPsec packets, so you have original packet and then IPsec headers in that. Trojans are like that, that you have some normal file or folder. In that, they will go and put some malicious code. That is the Trojans, that they can attack to the system. Once that user, they will think that everything is safe, all of a sudden they can go and attack the system. Ransomware, again, we have discussed about that. Just someone can go and encrypt your system and then they will ask money to decrypt it. Spyware is something that they are hiding, they are hidden code, and they can go and gain the access related to user behavior. They are like a spyware. They are hidden and then they are doing their job. Now, all these forms of threats that you are seeing here, actually, they are part of malware. All these threats that we have, they are different. And within these viruses, you have n number of viruses, like, Friday, day zero virus and all. Then you have n number of worms. Then you have n number of trojans, ransomware. Different means they have different categories you have. And to protect from them, you have to go and use different type of techniques as well, right? So yeah, I mean, like, most of the things will be covered if you have good next generation firewalls. So next generation firewalls can go and protect from these attacks, but still, I told you that security is always within layer. So only firewall will not protect from everything. Then you need sensors, then you need DNS security, then you need switch level security, router level security, physical security. Like that, you have to think all the stages, you have to go and think. And after that, you have to go and think about the role-based access as well, because it is something that is written in the book, like 90% threat is inside from the employees. So employees already, they have access to the inside network, right? And then if they want to do some malicious activity, then how we can go and protect that? So that's why we are using some sort of defining the role-based access. That means that if someone need that much access, then only give them access. Unnecessarily giving full access is not required to all the different teams or different type of team members, and etc. Right? Do you have any question? Please feel free to ask.
No, no, I think I'm good here.
Okay. So you can see this DOS attack and man-in-middle attack. DOS attack means unnecessarily someone will go and send too many packets. The system will overwhelm with different type of packets. And DOS attack may be TCP DOS attack, ping type of DOS attack, DNS type of DOS attack. So DOS attack is there in all different type of services. Man-in-middle attack, A and B, they are doing some communication. In between, C will come and try to intercept the communication. That is the MIMT, man-in-middle attack. For such type of security, we can go and use IPsec. If we have IPsec tunnel in between two routers, if someone will go and try to intercept the message, they will get some encrypted message. They will get some message which is very hard to decrypt. So such type of attacks are there. For that we can use one solution is IPSec tunnel with good encryption keys. For DOS attack also you can go and you have different type of modules in firewall and IPS IDS that if you get same type of information again and again, they will go and drop that packet. Like multiple ways are there for protecting from DOS attack as well. Then vulnerabilities, the vulnerability is something like related to operating system actually. You are running some operating system and those operating systems you are not patching time to time. Any type of operating system like normal end host operating system like Windows, or maybe operating system related to routers, switches, firewalls. All the time you can see that they have some vulnerability in terms of that. Suppose you have firewall and in that firewall it's running fine, but all of a sudden you are enabling some feature in that firewall and then you are hitting some bug. Now for those particular part of feature, when at the moment you'll go and enable, you're hitting some bug. If it is required to enable such type of feature, enable it. If it is not required, then do not enable. In case you are enabling that feature and then you are hitting the bug, then go immediately check with the OEMs and update or do some patching. Update that operating system, because due to that piece of code, due to that particular feature, you are hitting something, some vulnerability in the operating system, and you should go and patch it. So you can see that vulnerabilities are the software bug, a weak password, unpatched system, misconfigured system. Like that, you may have vulnerabilities. Actually, vulnerabilities may be hardware and software. Software that you can do patching, and hardware you try to provide some sort of physical security to hardware. So that's why we are putting in the rake, where that rake is there in the data center or in the office. Then we have some access card to open that gate. Only authorized persons can go into that area. So we have CCTV to track the movements and etc. Like that, we have the issues, and we can remediate. So we have the options, and we can protect from those options, right? Okay, so you can see this is the feature. Then you can see exploits. Exploits is something that someone can go and try to exploit the running system. Yes, exploit can a specified method or technique used to take advantage of vulnerabilities to carry out the attack. This is interesting that you can see buffer overflow. It can be in the switches. So switches, what generally they are doing, that they are learning the MAC addresses. Attackers, what they can do, that they can go and flood that, because switches has some fixed numbers. For example, I have one switch and it can learn 4,000 MAC addresses. Somehow I can make some arrangement, or somehow I can do some attack to this switch, that it will go and learn more than 4,000 MAC addresses. Means if I go and connect some Linux server to the switch, and Linux server can go and generate some script that after every 1 second it may generate 1,000 MAC addresses. So in that case, switch has to go and flood their CAM table, the MAC address table. So that means that next time if any request will come, it will broadcast to all the ports, because anyways it has learned that much MAC address, and it is flooded. So it's CAM table getting flooded. So next time the request will come, the switch will work as a hub. It will not work as a switch. Like that, you have the buffer type of attack. Overflow, you can see the attacker, where the attacker send more data than the buffer can handle, causing it overflow and override the adjacent memory, potentially leading to arbitrary code execution means, again, yeah, there are very easy examples, like, easy examples. And there are backtrack and different type of Linux systems. They are coming with all those tools that they can go and generate n number of MAC addresses. And this is not only related to MAC addresses. This can be related to any type of memory leak. This memory leak can happen not only with the MAC attack, but maybe with the IP routing attack. Means someone can go and overflood the routing table. So next time it will not go and learn more routes and all. So these attacks are actually very planned, and it can be carried out with some planning. Whenever some attackers, they are attacking the system, then they they have the plans. They will not simply do the buffer overflow or the things. You can see SQL injection, you can see cross-site scripting, privilege escalation. This is related to role-based accesses. Cross-site scripting is there. SQL injection. These are the programming type of attack. Like, SQL. SQL is one type of database. So someone can go and exploit the uh, code-related behavior, and they can do some SQL injection, and they can gain the access in the database. Like that, we have the SQL injection. Cross-site scripting is also like that, that attackers can inject malicious script into the web pages to gain access to certain sites and all. Then privilege escalations are there. Privilege escalations means that someone can gain the access, uh, privilege access to the system. Right? Do you have any question on that?
I have one. What tools can we use to see or check or monitor any of of these types of attacks? Like if we having like someone is trying to do an SQL injection, like how can we know if that is trying that someone is trying that?
Yes, so we have these modules within the firewalls and the security appliances. So someone is doing SQL or this XSS attacks, you'll come to know. We have such type of techniques that can protect from such type of attacks. So these attacks, how they are carrying? These attacks, they are carrying via some code, right? Behavior within the code. And we have these modules in our firewalls and the security appliances that can go and detect the anonymous behavior, like behavior that is deviating from the normal behavior. So when someone is doing SQL injection, obviously they will come with some code, like some script. And firewalls and other IPS IDS sensors, they can detect. They have, like, these are very famous attacks, And the security appliances, they have the modules to protect from the SQLs and cross-site scriptings. They are like, they are the top type of attacks. And we have the security appliances, they have these modules to protect from them. Now, what they can't protect is that someone is doing some cross-site scripting with some other language that my firewall or my IPS, they don't know that language. And by default, they will allow that traffic. Then that traffic can go and hit to the server, because the goal here for these attacks to reach where is your server, because in the server you have the database, and within the database you have, they can go and inject certain codes within the database. So next time if some query will come to database, their response will get changed. At the moment we are just seeing that what are the attacks and what are the remediation things, tools. But point here is this, that these are these are big actually. If you go and learn, if you go learn deep into this, like CEH courses and cybersecurity courses, then you'll come to know that behind the scene in SQL injection, you may have 100 types of SQL injections. In XSS, you may have 50 type of different type of scripting attacks, like that you have. And then what are the remediation tools that you will come to know that most of the things the security appliances will do, because they have to update themselves. These, like, these firewalls, the next gen, they have to update their databases to protect from such type of attacks. So mostly they will do it, but again you have to go and provide the security at all the levels. Not only firewall, you have provided security and you can, leave it. Then you have to go to server. Over server, you have to install some hips type of settings. Then you have to check the connectivity in between. So where is the server connected to the routers, switches? If it is connected to the switch, then you can go and provide some security that it should, you know, allow only certain VLANs, certain uh, DHCP request and all those things like that. Should go and plan it, like, point by point, point by point. So from the internet or from the ISP, when it will go and hit your perimeter, you should go and uh, install DDoS appliances there. From DDoS appliances, it will come to your core router where you have some security measures. From core router, it will go to the gateway firewall, the traffic. Gateway firewall can block certain things. From gateway firewall, it will go to the core switch where you have IPS IDS sensors, where you have some load balances, SSL security, like, you have the set of security appliances there. And from there, it will go to the distribution access switches. There also you have some sort of security. Like that, you have the wall of security, like level 1, level 2, level 3. So then only you can go and protect from these type of attacks. And nowadays, the enterprise network, they have this such type of security walls that can be, so these can be protected, but still attacks are happening, and we should go and take the countermeasures, like how we can go and protect our system. So security is something that will evolve time to time. Now you can see the mitigation technique, IPS IDS sensors. Not only you have the gateway firewall, but you have the sensors within the network, regular software update, a strong password policies, education to uh, educations to not only the client but the employees as well, access control. These are the mitigation techniques. These are the standard mitigation techniques that we should go and use it. And then I have created one table here. You can see the threat, vulnerabilities, exploit, mitigation techniques. This is just a summary for your
Mm.
reference, right? You have any question?
No, no, no. Okay.
Right. So next topic, in CCNA, they have given like describe security programs element, user awareness, trainings, physical access control. Should companies should run this awareness training and program, and we know that time to time, like every month, we are getting some 10 minutes or 15 minutes course to complete, that do not click to the unwanted link, do not click to the outside attachments, do not send emails to outside your network, do not receive emails from outside your network, like email level security. Then put a strong password, at least 13 character password with mix of alphanumerical and special characters and small and capital letters, etc. And then while logging to the system, logging off to the system, do not leave your laptop and log out from your system. Whenever you log out, just lock your system and then go outside, etc. Use your access card. Do not use this tailgating, etc. In your desk. Make sure that you not put any username password in your desk, like, someone is writing username password and IP address schema topology, etc. Those are the awareness programs actually that most of the organizations, they are running it. there is one attack, like there is social engineering that is, you know, I think 1990s, that social engineering was one of the popular attacks. So someone outside your organization, they are, they are doing some friendship and going to bars, drinking beers and all those things, and then they are sharing their important information within the organization and all those things. So they are social engineering. Try to avoid falling victim of such schemes. Even I can see that this is quite often in India, that they will calls, you'll get some call, and over the call they will tell, oh, you won this prize, and you have, if you want to claim it, I will send you one link in your mobile phone. Just click that link and your prize will get and, you know you will get that prize in your bank account, and you'll get that credit and all those things. And generally, like, poor people, poor in terms of, they are very much needing of money, and they have very less, income, money saving in their bank accounts. And these fuckers, you can see these hackers group, and these fuckers, what they are doing, that they are stealing money from these poor people. And I feel very sad for them, those people, that they are doing such type of things to those, they have very less income, and they're stealing money because they don't know all these things. They have simple
Yep.
bank account, and stealing money for them is not a good thing. Now, I got victimized from one of the attack that happened to my PayPal account. So what is that? TikTok Chinese, China group. Uh, so I sent some $1,000 for some services somewhere, and my PayPal is linked with my credit card. Generally, I'm not linking my credit card for international transactions, but if I have to do some international transaction via PayPal, so I have to link it. I linked it with my credit card, and they still $300. Actually, they have done a small transaction. Actually, they haven't done $1,000 transaction or $2,000 transaction. Why? Because if they do big transactions, first of all, PayPal will not allow that. In first time transactions, they are not allowing. So they have done actually 300 USD transaction from my PayPal account that is linked with my credit card. So you can see that how strong they are. Like, PayPal security is obviously is good. They are always, they are updating their security, and because they are in the e-commerce business, online businesses, so they have to enhance their security. I got message in my mobile that your $300, you have done some transaction to TikTok. Now, as a normal user, people may think, oh, TikTok, PayPal, that is legitimate transaction. That's okay. But when I check that, I found that I haven't done that transaction. Generally, when we are doing transaction, we are getting some OTP, one-time password, in the mobile phone. When we are putting the OTP, then the transaction is getting completed. Then I raised ticket with PayPal, and they refunded that money within 2-3 days. But you can see how insecure this is, that when you are connecting to the public cloud, security will drastically decrease. So you have to go and update and check all the time the logs and everything. And they have done some auto debiting as well. Like, not only that, auto renew thing they have enabled in the PayPal. So that means that they know the system, that where is the database, because this is database attack, because my credit card entry is there in the PayPal database with a username and password. So somehow they have reach out to the PayPal database with some SQL injection, with some cross-site scripting, etc. Or maybe they haven't done the attack in the PayPal database, because that is very secure. That means they have attacked in my Chrome, my laptop Chrome, right? So when I install some software, I thought, oh, putty, this is free. Let me go and install it, because I'm logging to the devices via putty or empty putty, etc. But what these hackers they have done, that within that putty they have added some more extra line of code. And then when I install the putty, and then I have done some bookmarking, like I have a, nowadays if you go and open any particular website, they will ask you want to store the cookies, like these websites they have some cookies means some sort of scripts, that next time if you go and open that website, so these cookies make that opening of website faster, and they have some memory as well. With these cookies, even the Google can track certain things, that what activities we are doing publicly over the internet. So these cookies are actually very, what you can see, that they are sometimes they are very harmful, because I may go to some attackers or some hacker website, and by mistake I have downloaded the cookies that is there in my Chrome. Sometimes I'm getting message that you are being tracked. Some antivirus they are sending you message that your activities are tracked, like that. So maybe due to that cookies, because generally when we are logging to Gmail or any other site, we are saving the username and password, right? So that is our tendency, saving the username password within the browser. So someone can go and steal my browsing history. In that, somehow they can go and decode the username and password, and then they can log in, right? So these things, like we should be aware. These things can happen. So changing the password is very important thing. Password change, social engineering, data handling. These things are something that we should take care, and do not expose your laptop. So one of my friend, uh, he has exposed his laptop to the public IP, and within 1 hour he got hacked. Fortunately, that because we belongs to networking background, so what we are doing, whenever we have to expose something, we are creating one VM, virtual machine, and then that VM we are doing some netting, and then that will be exposed to the outside world. So fortunately, that they have locked that was ransomware attack. They locked that VM, and then my friend he has destroyed that VM, and that's all. Yeah. But again, we have to think that if this thing will happen, how we can go and handle the situation. Those things will come, and those things will come with some experience as well. But until unless someone will get hacked, he will not go and use all the measures. Be very careful about these security issues. Sometimes they are very small things that we are not doing. For example, one of the switch. By default, all the interfaces are part of VLAN 1, right? Sometimes we are no shutting down the interfaces which are not in use. Shut down the interfaces if they are not in use. Do not use all the interfaces within VLAN 1. These are very small things. And these things will come into the picture only when we think security seriously. Like we should think security, we take it seriously. Otherwise, any day it can be hacked, because they can go and track the open ports. There are scripts that can go and track the open ports, and with those ports they can move inside the system, and they can initially they will go and put a small code, then they will go and put some more codes, and then they will hack the system. So training and education is important for those things. Physical access controls, those are the important things. Badging system, biometric access, security guards, surveillance, cameras, lock and alarms. These are the important things related to physical access controls. The slides are there, and again you can see that the summary is also there. Up to you that you can go through it. Like these are just the theoretical slides, but yeah, if you go and implement it, it will take, these are the time taking things. That suppose if you have to go and improve physical access control, the badging system you have to improve, biometric access if it is not there, you can go and put security guards and their rotations, cameras, lock alarms. So it will take time. You have to go and find that what is the loose end in the security, and you have to tighten that, loose end. Like that you can go and provide the security. Then next is access control. This is something that we know, and since we are in CCNA level, CCNA level, you don't have different type of a privilege level example that you can go and create in Cisco routers and switches. So access control, one of the mandatory thing for access control is Cisco ICE, identity services. Not Cisco ICE, but any type of identity services like ClearPass is there from Aruba, that is also very popular. From Cisco, we have Cisco identity engines, service engines. The importance about this access control is this. Two important factor is this. First important factor is this, that do not allow or do not provide all the access to everyone. So suppose if you have security team, you have network team, you have a storage team, you have admins, etc. Create the group for a storage. So a storage team has access only to the storage devices. Network team has having access to only the network devices. In the network also, you can create a group for network team, like someone is doing only monitoring, someone is belonging to L1 L2 team, someone is there for L4 team, someone is like network admin. Now those admins, those users put some strong password, and for admin user and password, try to rotate that password every 1 month or maybe 15 days. If it is aggressive, 1 month is okay. Try to change that password after every 1 month and use some vault. Generally, all these username and password in a corporate, they are putting in vault, iVault or something like online vault or something, and provide security to the vault as well. The vault access will be granted only to two, three key persons in the in the group, in the company. And even if all these three key persons will go and match their key, then only they can open the vault, right? So we have the vault concept, like we are putting the username password in the vault, and this vault having three keys. So three persons, when they sit together, then only they can open the vault, and then they can change the password, and then they can share with different groups. Like that, the security measures are there. Now, with respect to local username password, do not provide privilege 15 to everyone. Do not use admin username and password. Use some privilege 2, 3, 4, 5, 6, and then you can go and lock those interfaces. Those are open. Generally, we'll see that in the enterprise, we are using we are not using login local. Local is there just to the fallback, but first authentication with AAA or ICE. So either it's line VTY or line console line VTY. First line of users will be from ICE and fallback will be local. Like that, we are providing the security. Then you can go and use service password encryption. It will go and encrypt all the plain text username password in the system. So if you go and use it, the name and the password will get changed after using this command.
Okay.
Normal. Yep. We will do all this. This is very small. Even in the SSH also, when we are doing, when we have done this SSH class, at that time also we have created username and password, username, admin, password, some Cisco or admin, etc., which is not a good practice. You should not use password like this. You should have bigger password, and you should have some special characters and other things.
A quick question there, Ranesh. For Cisco accounts, can we use two-factor authentication to log to
For
the
everything we can
Cisco?
use MFA. Cisco having their Duo, with that you can do MFA, multi-factor authentication. Yes, for Cisco ICE, for Cisco DNA, for Cisco SD-WAN, everything can be integrated with two-factor authentication, and we should do that.
For
but
Duo
not
is
not
from
not
Cisco, right?
for,
Yeah,
yeah,
Duo
but
is
not
from Cisco.
for a Cisco switch, right?
Cisco switch, how we can do two-factor authentication to Cisco switch? Cisco
With
switch, what
game
we are
moving
doing
traffic.
actually, yeah, those are for web browsing. Like, when you're browsing certain HTTPS sites, then it will ask you. But for Cisco, how we can do? So how you're accessing to the devices
Mm, right now
With
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 user
some jump
and
host,
password
right?
only.
With some
Yeah,
jump host,
yeah,
right? Like
yeah.
you go to some sites. So nowadays, how it is, like people are using maybe Azure desktop or some VDI to log in. So VDI or Azure desktop, virtual desktop are first level of security, because if you log into VDI or Azure, you may have some multi-factor authentication, like some code will come to your mobile, or you have some Microsoft authentication in your mobile. At the moment you log into VDI or Azure desktop, username, password, and then this mobile authentication will happen. Now once you log into that, once you reach to the desktop, then there you may have secure CRT or putty, right, where you can go and log into the device. So at the moment you log into the device, like routers or switches, then obviously you have TACACS policy. According to that TACACS policy only, you will log into the routers or switches. Now suppose my TACACS policy will allow me that only you have read permission. So if I have read permission, I can read the configuration only or certain commands only. I can't run any command on the routers and switches. So they are safe then, right?
Yep.
Yeah, but yeah, two-factor authentication directly is not there in the routers and switches, like
Okay,
MFA
yeah,
tag.
got it.
That is there in the web browsing. And but there are companies who is providing some more security to these routers and switches. So when you are logging to the routers, then first of all you have to raise one ticket, like what is the time you want to log into the router. Suppose you have your activity is for 60 minutes. So for that 60 minutes only, that window will open and you will log into the router. Once you log into the router, you will get some extra piece of code or some password. That password is valid only for 60 minutes only. So once you log into the router after 60 minutes, if you try to log in, you can't log in because your password is valid only for 60 minutes or maybe 30 minutes. But before reaching to that point, you need some approval, something, some IT tickets, all those things. And then you are logging to the device. And there are companies which is providing such type of services, and using these services, obviously security is increasing, no doubt. So at the moment you'll go and increase the security, user experience, or even the employee interaction with the devices will decrease. So suppose if I have to log into a router, and for that I need 5 permissions, then I will never log into the router. Why I log into that? Right? If you go and increase the security, the complexity will get increased as well. Like it will become complex. So suppose to reach to your office, you need 5 different type of access. Then if you want to go to office, you'll tell, oh, I'll not go to the office and reach to my firewall physically. uh, Like that means this security, obviously you can go and increase this level of security, but increasing the level of security, it will go and increase the complexity as well. So that's why we don't want unnecessary security as well. Sometimes people are telling that do not put $100 lock to $10 door, right? So it depends, like security always depends. There are all the security features and this and this and that, but it depends upon our requirement as well. How much security exactly we need, right? All right, so next topic we have, let's move to the next topic that we will not do today, we'll do tomorrow, tomorrow onwards. So 5.4, we have this security password policy elements, complexity password, etc., etc. We'll discuss these things and remaining topics. Where we are, let me quickly go to the agenda. So we discuss about 5.1, 5.2, and 5.3. 5.4 and 5.5, only these two things we'll do in next session. I think tomorrow we have Python, right?
Yes.
Yes, tomorrow is
Tomorrow's
Python.
Thanks for joining. Day number 18, we are continuing our CCNA security topic. Today, we have to learn other security topic. You can see 4 pointers here. We have pointers in 5.4, 5.5, 5.6, etc. And then we'll do the lab related to site-to-site VPN. So that's the agenda for today's session. Let's proceed on this agenda. So you can see that these are again the basic things as per our new CCNA version 1.1. This is the agenda that describes security password policy elements such as management, complexity, password alternative, MFA, multi-factor authentication, certificates, biometric. Point here is this, that when we are using this password like username and password, this username and password, we should follow some complexity. As per the security standard principles, they are telling that your password should be minimum of 13 characters with mix of different types of characters, alphanumerical, digit, small caps, etc. And you should change your password after every 90 days, or if it is aggressive, after every 30 days. Like that, we should go and provide the password and we should change that password. Now in Cisco networking, how we are doing this? Basically, we are maintaining, managing these passwords via the Cisco ICE. Within Cisco ICE, we have feature Tacicus. We can go and create Tacicus policy, and from there, we can manage this password, not only this password management, but password management authorization as well. So once someone will get authenticated with router, then as per their label, he is working as a L1, L2, L3 admin, network admin, observer, like that. There are different groups. We can define them in different groups. Even they will get the authentication and authorization. After that, also as per their access label, they can go and configure the routers and switches. Right. So two things are there, that complexity, obviously the management and complexity of password, and then once they will get authenticated, how much access they have related to those services. Apart from that, if you are working on SDN services like Cisco DNA, Cisco ICE, you are logging to Cisco SD-WAN or any type of servers where you are using the HTTPS services to log into the server. So at that time, we can go and provide multi-factor authentication as well. The example for this is, for example, Azure. If you go and use Azure services, then what they are doing, that they are providing Microsoft Authenticator app in the mobile. So at the moment you'll go and use their services via HTTPS, some code will pop up in your mobile phone. That is first level of authentication. Or maybe first of all, you have to go and give username and password. Once you go and provide username and password, then the code will pop up into your mobile phone like 88, 77, 66, etc. And once you go and put that particular code, then only you can access those services. So that is nothing but multi-factor authentication. In Cisco, we have Duo, Cisco Duo, Duo, Duo. that is doing the multi-factor authentication. It is also very much like Azure behind the scene, or any type of cloud services behind the scene. They are doing their MFA. Cisco is also doing their MFA. Apart from that, you can see certificates and biometric. Biometrics is something that is there to protect the gates. So someone, when they are providing the security to data centers at the gate level, they may have their fingers, like physical identity of body that can be scanned, and that can be part of biometric authentication. Then we have certificates. Now you can see this certificate is important because when you are creating policy related to IPsec, either IPsec point to point or IPsec point to multi-point, or you are using SSL VPN, that is clientless VPN, in those cases you have to go and provide the certificates. So certificates are something that whenever you are using HTTPS stand for secure, HTTP secure services, at that time parties, they will go and exchange the certificate, and as per the certificate they can go and grant the access. Now these certificates having some attributes. This certificate can get expired. Suppose if someone is doing CCNA certification, they are getting this for 3 years. After that time period, someone has to go and do recertification. In this certificate, a certificate mention what is the organization name, what is some sort of hash code. So it has some attributes. Certificate can get expired. So in terms of security, or security in terms of security, are providing better security, certificate should get expired and it should be renewed. So time to time, you have to go and check the certificate expiry date as well. Now let's move to this security password policy element. And password management, you should have the complexity in the password, and you should not use the same password all the places. There should be complexity in the password. Plus you can see the account lockdown. That means if someone can try password for more than 3 times, then his password should go and lock for 30 minutes or 2 minutes or 1 minute. Then even the account may get locked for 24 hours. Like such type of security we can go and provide. Such type of security we can go and provide in the routers and switches as well. But again, the login password, when we are logging to the devices, it is better that you integrate your devices with some identity services engines, maybe Cisco ICE or maybe non-Cisco ICE, but it should be integrated with some third party management tool. Password must be changed every 90 days. If it is aggressive, every 30 days. Users cannot reuse any of their fast last 5 passwords. Account will be locked for 15. These are the standard practice. We should follow these practices. In case if the devices are not integrated with identity services, you can log into the devices and you can set these via the CLI as well, but that will not scale, because in that case you have to l- create such type of policy to all the routers manually. You have to log into all the routers and create it manually. Then password complexity, you should give password not like this or this. It should be at least 13, but Cisco document telling that 12 characters, but 12 or 13 characters in length. Then it should be mix of uppercase, lowercase, a special character, number, right? So these things should be there, and you should avoid that what's the personal information like birthday, names, and all those things. Generally, we are doing this. Mobile number, 4 digit, birthday, names, your favorite person names like a sportsman and all those things. Generally, we are putting password like that. That is easily guessable password. Why we are putting such type of password? Because the password we also want to memorize, like in a net banking or any type of online things when we are doing. Same password we are using at a Gmail, same password we are using as a corporate email, because all the time we have to use that password and log into the devices. Sometimes we are using same password to log into all the places just to memorize, but that is not a good practice. At least the corporate password should be different to the personal email addresses and other resources, other online resources. Then yes, MFA is there. Cisco has their Duo. uh, Microsoft having their own password services. What is happening actually, after putting the username and password, that query is redirected towards the cloud, and over the cloud it will get authenticated over the cloud portal, and again you are getting the grant access to log into the devices. Combining a password with hardware token like a UB key means, yeah, again it is part of security. If you are putting stronger security measures, then you have to go and use such type of methodologies. Then certificate. Today we are going to discuss about a little bit of certificate and password policy as well in the lab, and we'll go and configure the IPsec tunnel in between two devices. But you can see the attributes of certificates, that they have some private and public key. They have some certificate authorities, and certificate revocation will be there. Mechanism to revoke the certificate if they are compromised. Plus, they have some expiry time as well. Say they have some timers as well. Using digital certificate for VPN access. Yeah, when we are using this VPN. So, for example, if I go and use my AnyConnect, this is one of the client-side VPN or site to multi-site VPN example, where one site you have the server or you have the router, but other side you have some agent. This is nothing but the agent. So if you have such type of arrangement where one side you have the server and other side you have multiple devices, then you can go and install such type of agents or software, and once you are installing such type of agent or software, they should be signed with some certificate authority to get access. Biometric, already we have discussed that the different elements are there: fingerprint, facial recognition, retina, etc. And here is the summary: password management, complexity, MFA, certificate, and biometric. You can go and check these points, and according to that, you can harden the system. The next very important topic we have is related to IPsec VPN, and then we have something related to wireless security. I already told you that for this wireless, we have one session. So all wireless topic I am putting together in one session. So these 5.9 and 5.10, I will take it maybe next to next session will be wireless, or maybe tomorrow. We'll see. If I complete security today, then next session will be wireless. I'll go and cover everything in the wireless. All right. The next topic, you can see the list of topics we have here is IPsec VPN, then configure and verify access list. This is actually very easy that I'm going to club within this. So these topics I'm going to cover together. And then we have layer 2 security. Then we have AAA, authentication, authorization, accounting concepts. This is just the concept because we are at the CCNA level. And then wireless security. So I'm going to cover only these topics today, only these two topics. And then next class, we will go and discuss about 5.7, 5.8, and remaining topics. So let's move to IPsec VPN. IPsec VPN, how it is, why it is, those things we are going to learn today. And we are going to check that in the lab as well. There are actually two different types of IPsec VPN. Either it is point to point. So if you go and connect two servers or two routers together, you'll get the VPN. That VPN type is point to point or site to site. But in case you have one server and other side you have just the receivers or the clients. And then if you are connecting, this is point to multi-site or site to multi-site MS. That means one side you have server, other side just you are installing some sort of a small agents. Maybe any connect, global protect, those are nothing but the agents. So you have some small agent software and you are installing those agent software to other side like any connect or any type of agent, but 90% of configuration or 95% of configuration you are doing to the server. Now this point to multi-site VPN or site to multi-site VPN, these VPNs also having two flavor. They may be agentful or agentless. Sometimes it is called as a clientless. That means you don't need to go and install some sort of software like AnyConnect or Global Protect, but still it will get some information from the server and then they can work. But that type of VPN having very limited scope. Limited scope means whatever configuration you will do at the server level, only those access they have, only those type of accesses they have. And such type of arrangement, you can see such type of arrangement is true with any of the cloud provider as well. Clouds provider also they are providing SD-WAN type of features, point to point VPN type of features, and point to multi-point type of features as well. So let's go deep dive into this site to site VPN, how it is working. Okay, and before I go there, I'll give you a small brief. So when you are creating site-to-site VPN, obviously in between you have some ISP. So these two sites, their WAN interfaces is connected with ISP. WAN interface is connected with ISP. This is the WAN facing interface where you want to create the tunnel. So while you are creating the IPsec tunnel, they should know their WAN IP address. That means as long as two devices having the IP reachability, they can go and form the site-to-site VPN tunnel. So here important points are like this. While you are creating the IPsec tunnel, the important point, let me go and change the colors, you can see it. So what are the things you should do? Again, you will come to know in the upcoming slides that we should go and create the crypto ISACamp. What is this? I'll explain policy. Then you should go and create some crypto IPsec policy. Then you should create some access list that will use for that allow the traffic between the. So once you have the VPN tunnel, you don't want to send all the traffic via this VPN tunnel. So you can create some access list and only that access list will be part of this IPsec tunnel. Only that traffic will go to the IPsec tunnel because we'll go and define such access list in the IPsec configuration. So you'll understand that. Then we are creating some sort of crypto map and finally we are applying this policy. Like some steps are there for this IPsec tunnel. Now this ISACAM policy that you're seeing here, ISACAM, what is the full form? Key Management Protocol, Internet Security Association Key Management Protocol, ISACAM policy or ISACAM policy. This is something known as phase 1 of IPsec tunnel. So what we are doing that we are creating the framework. Actually, IPsec tunnel, when we are creating IPsec tunnel, although it is one interface, but behind the scene, it will go and create two different type of tunnel. One tunnel is for control plane and one tunnel is for data plane, where actually we will send the frames. And one tunnel is there to just exchange the control packets within the IPsec tunnel. And both the tunnels, the ISACM phase 1 and phase 2. Phase 2 is actually to send the traffic, IP security, to send and receive the traffic, that is for the actual traffic. And ISACM is for control tunnel, where we are putting the security measures. Actually, we are putting the security measure both at place 1 and place 2, but place 1 or phase 1 in SACM policy, we can go and do some certification process as well. Either we can go and put the manual certificate, or we can go, either we can go and put the manual password, or we can use some digital certification as well. Um, that's to protect the control information in between two endpoints. Why we are protecting this? Because this IPsec tunnel can be over public cloud or public uh, better right, internet. The media can be internet, your access may be internet, it may be MPLS, doesn't matter. As long as you have the IP connectivity, you can go and form the strong IPsec tunnel. And why we are using this? Because the connectivity is over public transport or over the internet. So that's why we are using such type of connectivity. Right. Now, what we have to learn here, we have to go and learn what exactly is this protocol ISACMP, what exactly is this protocol IPsec, right? IPsec, IP security, the full form is IP security, is full-fledged protocol. It's like suite of protocol, like it's a suite. Within that, you have different type of security measures. So what type of things we have? Let's see. Let's see here. So IPsec, you can go and create remote access or point to point. For remote access, you need client software and all those parameters. That's fine. Yeah, you need to do client configuration, like we have Cisco AnyConnect. And for site-to-site VPN, we will go and do the configuration. We are going to follow the steps. Remote site configuration also, if you want, from your Palo Alto, from your FTT, you can do the configuration. This is what is there in CCNA. You have to understand this much only. Why we are using IPsec, why site-to-site, remote access, what is the encryption, use case, scalability, etc., etc. But again, I told you that we are going little bit beyond this coverage of CCNA syllabus, and we are going to learn that how we exactly we can create the tunnel. Now, while creating the tunnel, I told you that there is one point that will tell you that create the access list. So you will go and create the access list. That means you have access list A that you want to send towards access list B, or access list of site A can go and communicate to the access list of site B. So for that, we should know first of all what is access list and how we can go and create it. Access list, we have two flavors, standard and extended. Standard is just based on, you can see, IP addresses, and the number is 1 to 99 or 1300 to 1999. If you are using these numbers, you are creating a standard ACL. If you are using 100 to 199, 2000 to 2699, these numbers, while creating the ACL, you are using extended ACL. In extended ACL, you can provide the IP addresses, protocols, port number. Means you have the granularity that you can go and put more information while creating the extended ACL. On other hand, a standard ACL, they are very easy, and they are worked based on filtering the IP addresses. So while creating this, it's very easy that give the name and create it with some IP addresses, and then you can use this ACL maybe at VPN level, or maybe at NAT, maybe at route map. Means you can create the ACL, and that ACL block can be reused in any other features, any other Cisco features, such as route map, such as NAT configuration, such as VPN configuration, etc. So usability is more. Even you can use it in the QoS as well, quality of service configurations as well. So here you can see a little bit more about the standard ACL. Oh, this is extended ACL example. Here you can see that IP access list extended. You can give the name, and then you can give the statement in the next line. Permit TCP this equal to 80. We'll see that. Today we have example related to this. I may have created some examples. So here you can see this is a standard ACL example. Access list 10, and then the permit statement. You should give this a statement in the next line. So this is in the next line. Permit 192.168.1.0, 0.0.0.255.255, etc. And then you can go to the interface, apply to the interface. Easy. Create it, apply it. Then you can see the complexity in the extended ACL. This should be in the next line. Access list 110. This is because this is just the number based. You may have number based, or you may have named based. Let me create it so you'll understand. Uh, Let me go and create the ACLs here just to show you this. So access list, if you are creating number based, then your configuration will start with like this: access list. Oh, same line it is. If you are using this named based, then you have to IP access list or standard STD. Then you have to go to next line. But this number based ACL is in the same line. So this is actually in the same line. This is actually in the same line. But if you are creating named based ACL, then you have to create the name, and then you can see below the name, for example, permit 10.1.0.0, 10.10.0. Even I can press enter, or I can go and give the wildcard bit 0.0.0.25. So here you can see this name based example. If I have number based example, so it will start with access list, for example 10, permit 10.11.0, and then it will ask you the wildcard bit, right? So you can see two different variation: named based and number based. Number based, you have to give like create like this number and then add the lines. Named based is flexible. In named based ACL, why we are using this name based ACL? Because when you are creating the access list, name based access list, then they will give you some number as well, like 10, 20. So tomorrow if you have to go and delete some number, then you can go to that particular ACL. What was the name? And then simply if you go and do no 10, and you will see that number 10 is gone, right? So this name based ACL is actually a little bit easy to manage. And likewise, you can go and create the IP access list extended. You can give any name and then permit TCP. Even it can be working as a IP or TCP. You have multiple options that you can go and use. You can go and create the ACL based on GREs, ICMP, object groups, OSP, PIM, TCP, UDP, IP based, right? So permit say TCP. with some source wildcard. For example, I just wanted to match this IP. Then with this IP port number 80, and then I can go and give this IP. Oops, my system is gone. Wow. Let me reconnect. But yeah, what I want to show you that granularity is there. You can go and make it much more granular. That's the approach we have in this, and that's why you can see these examples here. Um, Here you can see the example. If it is a number based, then you have to give the number, and then you can give the long list of what exactly you want to do with the permit and the deny statements. Right, some more notes are there. And then I have this IPSec VPN state configuration. Before I go to that, please feel free to ask if you have any question. All right, so next we have the site-to-site VPN lab. This is not part of CCNA training, but why I have added, because if you understand this configuration, you will understand more that what are the planned way that we can go and configure this site-to-site VPN and what are the key components in that. So for example, in phase one, we are defining the ISACM policy, but with that ISACM policy, we can go and define the encryption method. We can go and defining the hash method, and then we can go and define the authentication. Either it is a key, like I'm using some key to the peer, or it can be some digital certificate. It can be certificate, it can be some pre-shared key. And then the uh, group maybe 2, 3, etc., etc. This is something that we are providing the encryption, very tight encryption like AES, advanced encryption standard, hashing, and this grouping. This is phase one configuration. Once you have this phase one, this is phase one actually up to here. Then you can see that after ISACM, in phase two, we are doing the configuration related to IPSec. IPSec. And in that IPsec again, we are putting the ESP, encapsulating security payload. This is nothing but the header. In that header, we have again we have AES, SHA, and HMAC. AES encryption and the SHA, the hashing, right? Encryption and hashing here also we are using in phase two and phase one as well. So we are doing some dual protection. Then once you have a step one and a step two, then you are going to a step number three. You are creating the crypto map with IPsec ISACMP. You are setting the peer address. You are setting the IPsec for the peer, and then you are matching the access list. I told you that you have to create access list as well. That from R11, what traffic will go to R12 under the IPsec tunnel or over the IPsec tunnel, right? So we have some access list defined that we are mapping within the crypto map. So this is actually phase three. Phase three means configuration part three, and this is configuration part four. Then finally, you will go to the interface. Which interface is this? This is the WAN facing interface. This is the ISP interface, and then you will apply the crypto map. These are the steps we are going to follow to build the IPsec tunnel. Okay. So first of all, I should know, I should be reachable to my peer address. That means router 11 should go and reach to router number 12 and over the physical interface. So what's the connection? They have connectivity show run interface E 0/1 dot 99. I think 2 is the other side IP. At the moment I'm not using this ISP and all. I told you that as long as you have IP connectivity, the tunnel will form. So I'm using this point-to-point configuration link, but assume that R1 is somewhere R2 is somewhere in between, they have some ISP, but R1 WAN interface can be reachable to R11 WAN interface can be reachable to R12 WAN interface. That's the assumption we have here. Okay, so let's do this. See, crypto ISACM policy, for example, 10. Encryption, if I type encryption question mark, you can see AES, DES, etc. etc. AES, I want 192-bit or maybe very tough, like 256-bit of encryption. Then hash, you can see hash, you have SHA-256 normal, for example, SHA secure hash standard 256. Authentication, you can see that authentication you can go and give Rivers, Samir, Adeline. These are the gentlemen who has created this digital certificate. So these are some sort of certificate based authentication, and this pre-share is easy, pre-shared key, but for this we have to go and provide the key. Then I can go and define the group. You can see group 114 Diffie-Hellman group, and this Diffie-Hellman group, I can go and use the smaller bit 1024, but you can see 2048 3072 4096. Again, I told you earlier in the class that security always depends. It depends that how much requirement you have related to security. You can't go and put flat 4096 bit of keys everywhere if it is not if it is not supported by the hardware, because to process such type of request, again hardware has to process this under the CPU, right? So while creating the key related to hashing or encryption, you should go and plan it, like either 256 bit or it's 1000 bit or 2000 bit, etc., etc. So planning is required for security. Likewise, you have to go and provide this key, ISACM key, unencrypted, encrypted word, for example, key Cisco address. You should know the peer address. You can see peer address. What is the peer address we have over the interface? Show run interface E0/1. Peer address is this. So my peer address is this, right? And peer subnet mask, let me see. That is not actually required, but by default it will take only one IP. This configuration is actually the part 1 of the configuration. Then what we'll do, crypto IPSec transform set. Say tset is my name, and then ESP SHA HMAC, and then ESP AES, like that I can go and create it. So this is nothing but part 2 of the configuration. Then I will go and create IP access list standard, for example, VPN, or for a VPN, like that. And then permit 10.1.0.0, 0.0.0.2552. This traffic I want to send over the IPsec, over the VPN tunnel. Then we should go and create crypto map, say VPN traffic. And here you should go and use the, you can see that you have options here. You can give some number. For example, if I go give number 10 here, IPsec ISACM. Now within this crypto map, this is configuration item 4, we should go and set peer. What's your peer address? This is your peer address. Set transform set. Tset is my transform set. What are the things we can set? You can see access list, right? Or let's see. Set peer, set transform, match address. So for access list, we have to go and use the match the access, match the address. What is the our ACL for VPN, right? For VPN is invalid. Do show run section access list. Why it is not taking? Let's see. It is not taking, you can see it is not taking the standard ACL within the VPN. What it should take? No problem. We'll do one thing. We'll create one more IP access list extended VPN ACL. And actually, you have to give source and destination. So suppose my source is this, because this is extended ACL, and I want to go to this access list. So I created one other ACL, VPN ACL, where this is my source and this is my destination. Source and destination, right? And now if we go to this crypto map and match address, and if you go and use VPN ACL, now you can see it is taking. So you can see that it is not taking the standard ACL. You have to go and define the extended ACL, and you can define what's the source and what's the destination. Why it is important, I'll explain you. Finally, you have to go to the interface. So interface E 0/1, and then you can go and apply this. So crypto map, what's the name of the VPN map that we are creating? VPN traffic. Like that, you have to go and apply. Now this is one side of the configuration. Now you have to go and configure other side as well. So other side configuration will be just the replica. This configuration will be 100% same. If you do not do same type of configuration both side, then it will never work. Then your VPN will never work. So let's go here and do this configuration. Other side configuration, your IP is different. For other side, peer will be .1. And then peer should be different. So we can go and give peer is this. Rest of the things are okay. I haven't created the ACL at the moment. I will go and create that ACL. So IP access list extended VPN ACL, but this time this is in reversed order. This is the source, and the destination for router number 11 will be 1.0. This is just the reverse. This is the source, this is the destination. On the other side, your source is 1.0, destination is 2.0 or something. Source is 10.1.1, destination is 10.2.1. His source is 10.2.1, destination is just a flip. Then we'll go to the interface. That's the interface E0/1, where we can go and apply this as a crypto map. Now, once you do the configuration, both side configuration, then your IPsec tunnel should be up and running. So that you can go and verify. So crypto map SA or so crypto S sessions. You can see this is showing active, but this is down. That is not good. show ISACAM ISACAM. So crypto ISACAM SA. These are the commands. Means you should see some status here, which is not showing because maybe my hardware is not supporting all those IPSec features. So this tunnel is not up, but this is the way that we are configuring the tunnel. Let's see. There are two things. If your tunnel is not working, either your configuration having some mismatch, right? Or your hardware is not supporting such type of encryption keys and bits and all those things. So why not? Let's go and check our configuration, and then we may go and flip this VPN tunnel. We'll go and shut this VPN. So let's see the configuration. Section crypto. See, crypto is ISACAM policy 10, encryption AES, hash is this, authentication pre-share, group is 2. Encryption, hash, authentication group. Then key Cisco address this. Then key Cisco address this. So reverse address. This is phase 1 configuration. Phase 2, TSET, ESP, AES, ESP, HMAC, TSET, ESP, that is also correct. Channel mode is channel, that is okay. Then crypto map, set peer.
Yeah, should we never provide the key?
Key is here, key Cisco.
Oh, okay.
Not a good key, but we have put that. Then peer transform set, match VPN ACL, and then applying to the interface. So we have done all those configuration actually. Correct. Yeah, everything is correct. So once everything is correct, then it should work. Let me go interface E1/0. Shut, no shut. Oh, E0/1. Let's see the E0/1. So it is apply over the interface. That's great. And let's go here and check. Do show run interface E0/1. E0/1. No shit. Show crypto ASA campus. Channel is not forming because maybe hardware support is not there. But apart from that, everything is okay. The configuration is correct. There's no problem in the configuration. You have the IP reachability as well. If you have IP reachability, if you have correct configuration, the tunnel will work. There is no problem in this. Both side we have the reachability. This is the way you can do the configuration. When we'll work on non-EVNG platform like GNS3 or other platform, then you can simply configure these items and it should work. What I'll do that we have an assignment, Python related assignment, where we are going to use the non-EVNG hardware. We are going to use GNS3 hardware. There we'll go and configure it via the Python. So I'll add this session, this particular configuration in our Python session assignment. So we'll do the configuration in other platform, other better platform, and we'll try to check this channel. Okay, if you have any question, please feel free to ask. Thanks for joining. Today we are in day number 19 and we are going to continue our security topic. Next topics we have related to layer 2 security, and the lab related to layer 2 security. You will find that within the assignment that we have, I think tomorrow. Yeah, tomorrow we have assignment day. So tomorrow, we are going to see these in action: DHCP snooping and port security. I'll add port security as well. DHCP snooping is also there, and rest of the things we'll learn. So today I'm going to cover 5.7, 5.8, and 5.9 and 5.10. They are basically related to WLC. So that also I will show you. Let's move in. 5.7. Configure and verify layer 2 security features such as DHCP snooping, DAI, dynamic ARP inspection, port security. Now, these are the easy topics, and these are layer 2 security topics. So layer 2 security features such as DHCP snooping, dynamic ARP inspection, port security is little bit related to port security. Means you have switch, and that switch is connected with some PC or some laptop. So over that interface where your switch is connected with the PC or laptop, how you will go and provide the security, that's related to port security. We'll discuss about that. Oops. Where is my port security? It's gone. Wow. Okay.
Hello, everyone.
Hi, thanks for joining. We just started. So today we have topic related to layer 2 security. In that we have we have to learn about 3 different type of security features: DHCP snooping, dynamic ARP inspection, and port security. So let's start with DHCP snooping, and the lab related to DHCP snooping and port security we will do tomorrow. Tomorrow we have assignment day. So tomorrow we are going to learn about those features, and tomorrow we are reverting back our timing, so we will be studying on the same time. Today I have some drop issue, so class has delayed by 30 minutes. But tomorrow the same time will start as usual, the timing that we have. Okay.
Okay.
All right. So you will see now these security features that you can see, they are actually connected. What is DHCP snooping? We should understand that via some example. In our lab topology, you know that in the assignment we have data center and HQ. So we have data center somewhere. Suppose this is my DC and this is my HQ. Within the data center, we have some switches. We have switch 211, 212, switch 201, 202, and here you have switch 110, switch 101, switch 102, and this switch 110 is connected with some PC. Now, this is the overall topology we have. Now in this topology, these switches actually, you will see that they have some connectivity, some backup link or replication link. But the placement of DHCP server that we have, DHCP server is in data center, and the host PC that you can see here, PC, they are in the head office. So PCs are in HQ. Now we have to go and configure DHCP server where, so we have to configure DHCP server here. From this DHCP server, the DHCP, the DORA process will start, and these PCs, you can see here, these PCs, they will get the IP address. Now, since you are going through one location to other location, so your server is somewhere and your clients are somewhere, right? So you want to protect these links. You want to protect these links, all the links. So you have connectivity from switch to this PC, then you have connectivity from switch to switch, then you have the link, replication link from DC to HQ, and then you have the link from the HQ core switch to the HQ DHCP server. All these links you want to protect, and all the security parameters are different. So here you have some different security parameters, here you have different security parameters, because this is your L3 link, routed link. Here you have some port channel, and then here you have some uh, access port configuration. This is your trunk interface, and this is your access interface. So all these places you want to protect, you have to go and use security measures in all these locations. So here in this replication link, suppose if I am running OSPF, I will go and use OSPF MD5 password security protection mechanism. I can go use some TTL security. I can go and use some advanced security. There are different type of security features in OSPF that we can go and use in within these replication link. Then what about these links? Now, since you have the DHCP server here, the port channel that you have in between, we have the port channel in between. The port will go to port channel and we'll go and give one command, IP DHCP snooping trust. Right. So the port channels that you are creating, you will trust the DHCP snooping. Again, I'll explain you what exactly that and those are. But these are your trusted link. Why these are your trusted link? So we are making a link trusted that is going towards the DHCP server. So if you are assuming that DHCP server is in this direction, all the links that you are making those links as a trusted link. Trusted links means that they will go and trust the DHCP packets. If it is an untrusted link, then these devices will never get the IP addresses. That's the usability, why we are creating trust, DHCP snooping trust, etc. Let's understand this concept. DHCP snooping is a security feature that acts as a firewall between the trusted host and the DHCP server. DHCP server and the trusted host. It prevents unauthorized rogue DHCP server from offering the DHCP server addresses, DHCP lease addresses to the host. So if you go and create this, it will go and create some sort of access list, some sort of database, and with that database, it will not go and take the IP addresses that is coming from any untested DHCP servers. Functionality: filter DHCP messages received on untested ports, maintain a binding table, IP to MAC address pair that have been allocated by DHCP server, only allows DHCP response on trusted port. If you do not make these ports as a trusted, they will not allow the DHCP messages. The configuration is, you can see that you can go to the interface and you can make this command, IP DHCP snooping trust. In our lab, what we are going to do, that over the port channel, we will go and enable that. You will see that in the lab. Apart from that, we can go to the interfaces which is connected with the host system, and there we can go and limit the DHCP snooping limit rate. The DHCP message rate also you can go and limit it. Right. So this is the feature related to DHCP snooping trust. Basically, it will go and create one sort of table, and as per that table, it will allow or disallow the DHCP server request. And if it is untested, it will block that request. Simple, easy, straightforward. Then what about DAI? DAI. Here you see, it's actually important. DAI protects the network from ARP spoofing attacks, because it's full from dynamic ARP inspection. It intercepts all ARP request and response and verifies each packet validity based on DHCP binding. See, DHCP snooping binding. That means that if you have DHCP snooping enabled, then only you will go and enable this DAI, right? So that means that DAI having some prerequisite. What it will do, it will verify the ARP packet to valid IP to MAC address. That means that the DHCP snooping and DAI, these two features will go together. That means if you are enabling the DHCP snooping, next you can go and enable the DAI feature. It will protect from ARP snooping. How it will be? Over the global configuration mode, over the VLAN IP ARP inspection, then over the interface IP ARP inspection trust. So this ARP you are trusting, and you are trusting the DHCP snooping as well. For DHCP snooping also we are using the command IP DHCP snooping trust, and for ARP also we are using IP ARP inspection trust. You can enable it over the VLAN, enable over the interface, and then you should go and enable this command IP ARP inspection filter dynamic VLAN 1, and then you can verify it. So two protection mechanism we have: protection from untrusted DHCP server and protecting from DHCP, and protecting from the ARP inspection means ARP is spoofing. Spoofing means someone can go and forge the identity, and it will go and try to send you forged packets. And since it is a forged packet, so you may think, the system may think that, oh, this is legitimate request, I should pass it or process it. And in that case, they can go and take the access to the system. So these types of layer 2 attacks can be protected. Then we have one very nice type of feature that is called port security. Port security is one feature that this will also I will add in the assignment, because it is here. How it is working? Let me try to draw something here. And let me explain you this. So how this port security feature is working, that you have suppose one switch, and in switch suppose you have interfaces. Now with these interfaces, these ports, you will go and connect the end host system. So suppose we have PC1, PC2. Now if your switch physical security is not that great, that anyone can go and remove this interface, and suppose this is hacker PC, hacker is going removing this interface and connecting this interface, and obviously he will gain the access in the network, right? So in that case, what you can do, that you can go to this port and you can limit the MAC address. So maximum number of MAC address that this port can learn is only one. So that means that if someone will go and unplug this device and plug other device, this MAC address is new, obviously this switch will deny and this switch port will get shut down. You can see options are there: shut down, restricted, protect. Either it will shut down that interface, or it will move to the restricted mode or in the protected mode. Actually, we have multiple options that we can see that what actions it can take. So not only this thing, that you can go and limit the MAC addresses, you can and reduce to one, you can reduce to two as well. Sometimes it is connected with, so this PC and IP phone, they are connected together. That means this interface wants to learn two MAC addresses. So you can go and add two MAC addresses. We have option there. We have option there. So for example, maximum two. Maximum two means that this interface will go and learn two MAC addresses. Here you can see, you have to go and turn on the port security feature, switch port security. Then you can go and allow two MAC addresses only. And then the violation, if someone will go and violate this rule, then it will restrict the access, or it will shut down the interface, or it will protect that interface. And even you can go and put some timers as well. There are timers as well, like aging timers and all those things, right? So it's easy, straightforward configuration. We will see this in action tomorrow in the assignment session. DHCP snooping, ARP binding, and all those things. So here you have one summary table. comparison in between DHCP snooping and DAI, dynamic ARP inspection. These are actually important features that we should enable in the over the Cisco switches. This will give you some low level security like layer 2 security over the networking devices. Make sure that what is the location of your DHCP server, how the request is coming from DHCP server to the core switch, distribution switch, and access switch. According to that, you can go and make the ports as a trusted ports or untrusted ports. If you do not configure anything, that will be untrusted. And then you can go and protect from the ARP spoofings as well, or ARP poisonings as well, that you can go and enable the feature dynamic ARP inspection. Then you have port security. This is like interface level security, where you can limit the MAC addresses, and if someone can go and violate the configuration, then they will get the limited access. Right? Any question you have? Please feel free to ask if you have any question.
Sorry, yes, I have one question. So by default, it is not enabled. Is
Default,
security?
none of these
No.
securities are enabled.
And I mean, I guess that it is recommended to use the three at the same time, right? Because
Yeah.
only having like the DHCP snooping
CCNA, we have only 3, but there are others as well.
okay.
Okay, there are good amount of security measures we have, and so if you go and check other security features, you have VLAN based access list, you have private VLAN concepts, like within VLANs you can create VLANs. Then you can go and protect from the spanning tree. So we have a spanning tree protections like root guard, BPDU guard, those type of features. Then you have uh, port-based access list configurations that you can do. So if we go and write all the security measures, that means you can go and create the VLAN based security. You can create VLAN based ACLs, ACLs based on VLAN. You can create MAC based ACLs. You can create IP based ACLs. And then the features we have like port security, DIA, dynamic ARP inspections, DHCP snoopings, even you can limit the rates and all. So nice security we have. When we are creating HSRP, then also we can go and put some password and some security features. When we are running EIGRP OSPF, there also we can put passwords. There also we have TTL security. There also we have good amount of security. Means in these protocols we have security, good amount of security. Not only these, but you can go and protect from the control plane as well as COPP, control plane security, COP actions also you can take. So good amount of device hardening. They are part of device hardening. If you go and check Cisco best practices device hardening, then you will get list of security features, and in that list of security features, Cisco will tell that what is the recommended configurations for these security features. Right? Everything, all the protocols, they are coming with some sort of security feature. So continuing this, now you can see that wired is okay. So far we are discussing about the wired security. What about wireless? Because remember, this wireless thing is something that is always on. No one is going and shutting down the APs and WLCs and all, always on. Office time, after office time. So someone can go and intercept the radio frequencies. And if someone is using WPA, then this password can be cracked within 2 minutes. WPA2 also, what is this wireless protection? We'll see that what exactly they are. But WPA2 also having some vulnerabilities. Then we have WPA3. So security measures are there, but then you will see that some sort of hacking techniques are developing. Then again, improvement in the security. Then again, some vulnerability, some hacking will happen. Then someone will come with 4. It will be there for 6 months or 1 year. Again, someone can go and break the WPA4. So like that, security, like defense and anti-defense, or security and hacking, they are going parallelly. Okay, so we have to understand this. I have created nice notes here, like, before that we have this concept, AAA. Okay, so I'll not skip that. We have to understand this AAA concept, and then I will go and cover this. I think slides are here and there. You should have 5.8 first. I will arrange the slide in this. Oh yeah, so no problem. This is actually easy concept. This is actually part of Cisco ICE. And maybe you know that I'm taking separate ICE classes, but those are little bit advanced, not basic. Although those concepts, those training videos are available in my YouTube channel for free. And if you go and simply search Cisco ICE, YouTube Cisco ICE, maybe first hit will be my video. Let me check this. YouTube Cisco ICE. See, this is my video. In second, because this video, I have so many watches and comments in this video. So if you search this video, it will be like number 1 or number 2. But this video, see, 29K views I have in this video, and 44 comments. So many comments also I have in this video. Point here is this, that actually this is good. This 2-hour video that you have. You can go and watch this 2-hour video. This is actually, let me put the chat, put the link here in the chat window. Yeah, you can watch this video. You will understand this concept of AAA, and not only you will understand the concept of AAA, but how we can configure it. That also, I think it is covered in this 2-hour video. So let this get completed. So many ads are coming. 1 second. Old video, I think 4 year, 2019. Yeah, it's 2019. Now it's 2024. Yeah, 4-5-year-old video. This is what is ICE and what is this, benefits, and all those things are there.
Do you have more videos like this?
Yeah, in my YouTube channel, yes, I have so many videos. I think more than 200-300 videos I have in my channel. I have videos. Even this CCNA training also I am uploading in YouTube. This CCNA training that we are doing, that is, I will share the playlist. So our videos are there in the YouTube channel, that you can go and have a look on. Yeah, so this is our videos that you can refer. Where we are. Okay, let's continue. Let's continue the class. Somehow mouse got stuck. So what is next? You must go and watch that AAA video that I have shown you. You will understand more about this. I'll give you the overview. This is authentication, authorization, and accounting. That means that someone will get authenticated then it will get the authorization to do something, and how long he is in the network, that is the accounting. So authentication is first request. Once he will get the once it will pass the authentication phase, then it will move to authorization, that what are the things he can do. And finally, when he is logged into the system, you should check that how long he was in the system and what are the things he is doing. That is part of the accounting. So this is the triple A method: authentication, authorization, and accounting. Generally, the triple A servers like ICE servers or ClearPass from Aruba, these servers, they are built to provide such type of security, right? And then I'll request you that you should go and watch that 2-hour video. You'll understand this fully. Now, how we can go and configure this within the routers, switches, firewalls? So first of all, you have to go and enable the feature, AAA new model. Once you enable this feature, then you can go and assign the radius and tachicus. There are two type of servers, radius and tachicus servers. So what is the server location? This IP is your ICE IP, Cisco ICE IP, or maybe ClearPass IP. So you are giving some name, then you are telling, okay, this is the IP, this is the key, and then you have to go and give the authentication, authorization, and accounting level of configuration. So it will start with AAA authentication or AAA authorization or AAA accounting. Remember, this is the part of configuration that we are doing in the switches or routers or firewalls. But you have to go and create the tachicus profile and tachicus policy set within ICE as well. Then only the switch, when you try to log into the switch as per your tachicus username and password, you will log into the switch. So the request will go to the tachicus server. You can see this line. This is telling the AAA authentication. Hey, AAA, I want to do the authentication for login, and my default group is tachicus group that should be defined in the ICE. In case your ICE is unreachable, it will go and check the local database. How we are creating the local database? In the router switches, we are giving one command, username ABC, privilege 15, password DEF. That is the local database. So if AAA is unreachable, if we have the local database, this request will be get authenticated to the local database. But point here that we should authenticate within the tachicus. Once it is authenticated, the request will move to the authorization phase. Same way as per our policy configuration in Cisco ICE, it will get authorized, and then you will get the COE. What is the change of authorization? COA, change of authorization. You will get that authorization. That means you can do, means as per your authorization in the ICE group, you are the admin group, or you are the observer group, or you are the layer 2 engineer group, etc., etc. You will get the access to do some configuration changes in the devices or not, if you are permitted to do that. And then that request will go to the accounting, that how long you are logged into the devices, what are the things, what are the commands you executed, etc., etc. So all three together will give you the security, that you are measuring the user activity within the uh, uh, obviously you are tracking all those things within the ICE. Anyways, you are logging to the devices, you can do anything as per your authentication and authorization. Actually, the power here is with authorization. As per your authorization policy, you will get the access, how much access you have within that network, within that device, right? Any question you have in this? I'll request you to watch that 2-hour ICE video if you have time. Try to complete this in this weekend, so you will understand roughly what exactly ICE is and what type of configuration you have to do within the networking devices as well. Both the things you will understand. All right. So as I told you earlier that we will go and do some wireless stuff. So I have booked the lab for WLC access. I will show you few of the configuration items related to wireless security. As I told you earlier that WPA 1 versus 2 versus 3, WPA, this is not 1 but this is WPA, Wi-Fi protected access, introduced in 2003. Why they have been withdrawn? Because they have weaknesses. The TKIP, temporal key integrated protocol, having some vulnerability, and it can be breaked easily. Actually, within 2 minutes you can break with some new tools. So web is still vulnerable or vulnerable to certain attacks and has been deprecated. This is something that corporates, they will never use. Corporates, they can use either 2 or 3. So now you will see the newest standard is 3. So 2 was there, you can see 2004, and certified after 2006, means from 2006 till 2013, I think, or till 18. See, 18, 6 to 18. That means 12 years, right? So last 12 years it was there, almost 12 years. Still people are using this, but it has some weakness. What weakness it has? That it is vulnerable to certain attacks such as K-crack. Even I don't know about this attack. Key reinstallation attack if not properly patched. So it has some vulnerability. Due to that, now we are moved to WPA3 announced in 2018, and you can see that all the features have been improved. Encryption, it is using SAE. Again, I don't know about this encryption. If you go and read about these type of protocols, you may get some 50-60 pages how this is working behind the scene. Was as encryption, we know that you have private key, public key, you can lock and unlock, but behind the scene they itself have some lengthy algorithm and mechanism that how they are encrypting and how it can get decrypted. uh, Simultaneous authentication of equals, that SAE, that will go and provide the security. Authentication provides robust protection when user chooses weak password. Forward secrecy, it has forward secrecy. Improve public Wi-Fi security features, it has, and strengths it has. Enhance protection against brute force attacks, and improve security for public and private network. So you can have a look on this feature, and when we log into the WLC, we'll see that. But you should go and enable that feature. Then you can see that you have the configuration. I'm going to log into the WLC. I will show you the steps how you can go and check this. Actually, the configuration piece is always easy. If you are doing via the GUI, you can go and look the configuration. Let me pull the server. You can go to WLANs, create new, WLAN general setting, create the profile, apply it, blah, blah. All those things are there. Steps I have added actually, layer 2 security, WPA, WPA2, select pre-share key and all those things. Let me pull that server. Let me go and show you that. So here you can see that I logged into one of the wireless controller. This is iOS XE based controller. Actually, there are two parts of controllers. Because of competition, Cisco has announced it. If you go and check the wireless network, you will see that within the wireless network, we have Aruba. That is the best. And then Cisco also having their wireless technology, right? Like WLCs, and then Cisco DNAC, etc., etc. In this WLC, earlier Cisco has introduced some radio OS like 3550, or maybe 3850. 3850 is a switch number. In this series 3XX and other series are also there, 5XS. These are something like radio OS. In these devices, you do not have configuration like you are doing like you're configuring your routers or switches. Then Cisco has introduced iOS XE based controllers. In these controllers, you can see one example is 9800 controllers. Even 3850 catalyst switch also can work as a controller with some limited functionality, or other catalyst switches also can work as a controller. But one of the popular one is 9800. You can see this WLC here. The good thing is this, that these are iOS XE based controllers, and if you go and log into these devices, so let me try to log into one of the controller. Oops. Enable. See, this is a controller, but the mode you can see it's very much like router. Show run. Like we are uh, putting configuration and routers and all. So, good thing. So you can see that AAA configuration as well. Although the font size is very small. Let me increase the font size. Let me do some changes here. Change setting. And where is the color? Here it is. Okay, a little bit better. You can see. Here you can see the AAA configuration that we are talking about earlier. But I'll not go deep in this. You can go and watch that 2-hour video. You'll understand most of the things in this. But you see here, the configuration is very much like what we are configuring in the Cisco routers or switches, right? Because this is iOS XE based controller. We have telemetry enabled. This is the net flow configuration. All these flow configurations, you have multi-link, CTS, Cisco TrustSec configuration related to tag propagation. Then you can see some QoS configuration, quality of service configuration, and all those things. Then we have some other configuration, but very much like this. So now, when people, they are deploying the controllers, what they are doing, that they are not logging to this GUI. Actually, they have some template, and as per the template, they are configuring the devices, right? They are configuring the devices means that they have some CLI template. Simply they are copying paste to the CLI, and then their GUI is configured like that. People are doing such type of configuration Cisco devices, and then once they are doing some base configuration from the CLI, then they are coming back to the GUI, and from GUI they are doing the changes. It's very much like reverse type of configuration that people are doing with the WLCs. Now, what we want to do here in these WLCs, that we want to configure something. You can see the tabs here, monitoring tab, configuration tab. If you go to monitoring, you can see so many monitoring options, DHCP, security AAA, application visibility, wireless. And then if you go to configuration, it's actually very easy and straightforward. If you go to configuration, it will tell you what you want to configure. You want to configure interfaces, layer 2, security. See, security AAA, ACLs. You want to configure this. You want to configure wireless access points. You want to go to wireless global. You can see if you want to go and do this wireless setup, you can go to that. I can go and add something here. Say I'll go and give pod 1. Now you can see local and flex. The type, again, you need to understand the wireless technology. You'll understand why we are using Flex. Flex has that the device, they have some sort of intelligence. Local means that devices, they are dependent upon the wireless WLC controllers. Then wireless network, that means you can go and add some SSID. See WLAN type. I can go and define because I don't have anything, so I can go and define one SSID. See profile name CCNA morning. Then WLAN ID is 1, by default it is 1. Now status enable broadcast is enable. Now you can see the frequency. Generally we are using 5 gigahertz or 2.4 gigahertz. If you want dual band, you can use it. The standard here is 802.11 BG. CCNA WLAN required. Now you want existing policy or you want to create new policy. I don't have any policy I can create. So now you can see that for pod 1 we are creating policy. What's the group of VLAN? You should give some VLAN group. Then do you have any IPv4, IPv6? And here itself, see the QoS policy. So I don't have QoS. Actually, we have some gold, silver, bronze. But if you do not have, you can go and create this QoS. Where it is? It is in configuration, services, and QoS. So if you are in the configuration, you'll see services. Within services, you have QoS, right? So I can go and add the QoS. And then you should understand these values that we have. Add class map. ABC, application visibility control. Match any, match all. Okay. This we are within the policy map. And within the policy map, I can go and match these values like these protocols, very much like CLI type of configuration. I can save this portion of configuration. And then you should match something. Let me show you something. You can go and search as well. You can see search on basis of categories, subcategory, application group. Why not take application group, Amazon group, save it. And now you have the policy. Ingress, egress, you can go and apply that to the devices. And it should work, it should save. Fill some dummy numbers here, just wanted to show you that it can be saved. Okay, again, so what is our policy name? CCNA class something. We can go to that setup basic. We haven't added that. Part 1 we have already created. Wireless network. CCNA we created. Policy existing, yes, we have created one. Policy name. QoS, you can see CCNA QoS, add it. And now we can go and apply it. So this is here in the WLC, right? Now this WLC should go and discover. So now you can see that we have wireless LAN here. One policy we have created CCNA. I can see, but what you need to do that you need to go and discover the access point which is not here, and then you can push this policy from WLC to access point, right? Now, what about security? Let's see. We want to provide security as well. So let's go and see that where exactly we have the security features. Should have security tab here. You can see security. If you go to the local policy, there are some local policies here. Let me do one thing. Let me show you this. Go to configuration and go to APs. I'll show you both the locations. You can go to the security. And this security, you have some other features related to security. What is RSSI? These are some frequency or something. Anyways, so from here you can put the security. Where is that authentication? Let's go here and see. I just wanted to show you the WPA and web. When we are putting this with SSID, we are putting those security. See, so many features are there. Client cap web tunnel. This is the tunnel in between the WLC and the APs. But the security that we want to put, that security is actually part of when your client, like my laptop or my mobile phone, wants to connect with the access point. At that point, we are putting that security. So that is part of SSID. Let me close this. Let me go one more time to the pod we have. And wireless network. So policy we have put COS Intel Authority. This is for ICE actually. You can go and put the ICE. Let's go to AP provisioning. APs are not here, so that's why it is not showing anything. So in this, what they have done actually, they have created all those pieces at different locations. So you can go and configure it first, and then later on you can go and add those features one by one. Like that, they have created the groups. So far, if you have any question, please ask. If you want access to this WLC, I can create the access and I can provide you that. Yep. Hello? No one is telling anything.
We are here with you.
I can give you that access as well if you want to just explore the things. You can see that I have created that CCNA profile, and I just wanted to show you this security feature. It's there. By default, it took WPA2. Let me go to this WLAN security. See, in wireless LAN, we have these options that we can select web WPA3, part of layer 2 security. And then you can see here that you have the SAE, OWE, FT, few of the things even I don't know about. I need to look into this GTK. So security things are there that we can go and provided by default. WPA plus WPA3 was there because still WPA3 is new. Maybe all of the devices, they are not knowing this. So then it is telling that select at least one because you are selecting WPA3. So Cisco 1, 2, 3, 4, 5. Give the pre-share key and all those things. FT is there. Okay. So for WPA3, we have to add some more features. Otherwise, it is not taking fast transition must also enable. I have enabled that. One of the AKM
It's
method.
not on the top on the status, fast transition status. You don't have to enable that. Oh, you guys.
Yeah, so one of the security feature we need to enable. That's why it was not taking, and then that's it. Then once you have these profiles and all, then you can go and apply it to or push it to the AP, and then it will work fine. Cisco, how much should I give? 3? Not much user friendly. Okay, so we are almost done with this. If you have any question, please feel free to ask. Next day, we are going to do the assignment.